All right, so we talked about sigma notation for series, and we've talked about the formula for arithmetic series, the number of terms divided by 2 times the sum of the first and the last term. So it would be nice if we also had a formula for geometric series. So let's find that now. So if we want to do the partial sum of the first n terms of a geometric series, in its very rawest form, all it is this. It's just the sum of the first n terms. Now, since it's a geometric series, we could replace each of these with the explicit definition of that geometric term. So a1 is just a1 because it'd be times r to the 0. R to the 0 is just 1. a2 is a sub 1 times r to the 1. I didn't need to write that one up there, but I'm going to. a3 is a sub 1 times r to the 3 minus 1 or 2. And a sub n is a sub 1 times r to the n minus 1. So all of these have something in common. They all have the a sub 1. So it's 1 plus r squared plus all the way to the r to the n minus 1. So this could be represented as that. Now this is still a messy formula because there's still that ... in there that doesn't help us. But this will help us. What we're going to need to do is we're going to need to think back to our polynomials. And a very, very basic polynomial. 1 minus x to the n. Now this binomial, it is factorable. And one of the factors of it is always 1 minus x. It's always 1 minus x. And the other factor, we want it so everything, when we distribute through, subtracts off to 0, except for these two. So if we have a 1 here and we want to make a 1 there, we'll need another 1. If we have an x to the n, a negative x to the n, and we have a negative x, we need a positive x to the n minus 1. So these two outer terms will produce that. But if we just multiply these out, they would have middle terms. So we need it so that all the middle terms will disappear. We'll subtract to 0. Well, we have a negative. When we distribute through, we have a positive and a negative. So in order for them to go away, we need one to stay positive, one to stay negative. So all of these are going to be plus. And if we distribute that, we'll have a negative x. So we'll need a positive x to counteract that. So plus x. And then if we distribute that, we'll have a negative x squared. So we need a positive x squared to counteract that, because the 1 times x squared. If we have a negative x times negative x squared, that's a positive x cubed. I'm sorry, negative x cubed. We'll need a positive x cubed to counteract that. And it would continue like that over and over again until we get to the end. So everything in the middle, all of those would counteract with each other with the 1 and the negative x to subtract to 0, leaving us just 1 times x to the negative 1. Wait a minute, that looks really familiar. What if we changed out the x's with r's? 1 minus r to the n equals 1 minus r times 1 plus r squared plus r to the n minus 1. Hey, look at that. Look at that, they match up. That's pretty super. So we can isolate that. 1 plus r squared plus r to the n minus 1 is equal to 1 minus r to the n over 1 minus r. So we can use that and replace that on the other page or panel, whatever it is, whiteboard. That's the word I'm looking for. So S sub n equals a sub 1 times 1 minus r to the n divided by 1 minus r. And that's it. This is our sum of a finite geometric series. All right, so that's our sum formula for a finite geometric series. So let's just try a quick example. Let's say we want to do sigma from k equals 1 to 5 of 3 times 2 to the k minus 1. All right, again, the k and the k match up. If you put that as k and then you put an n in there, I wouldn't take points off, but I just want to let you know these should always match up. Not everyone's going to be as nice about it as I am. So we could brute force it. We could just find the sum. And in fact, I'm going to brute force it and then show that the formula works. So the first term is 3, second term is 6. Then we're multiplying by 2 every time. So 12, 24, 48. So 6 and 24 is 30. 12 and 48 is 60. So that's 90 plus 3. It's 93. It's not always going to be that nice. And in fact, if these were not just very, very basic integers, it would not be that nice. It would actually be quite messy. But if we use the formula, our first term is 3, our common ratio is 2, and our n is 5. We need those three things because our sum is the first term times 1 minus our common ratio to the nth power, 2 to the 5th, divided by 1 minus our common ratio. Well, 2 to the 5th is 32. 1 minus 32 is negative 31. And 1 minus 2 is negative 1. Negative divided by a negative is positive. 3 times 31 is indeed 93. All right. So that's the formula. That's how you can find out the sum of a finite geometric series. All right. Have fun.